Hi everybody. Trying to be proactive here with the weather. My children's daycare shut down. My wife she has to go to work. I'm home alone, and I just don't think I'll be able to teach for an hour without one of my kids murdering the other kid. So I figured I would make a video going through the worksheet. I'll be back on Zoom towards the end of class to answer questions, and hopefully I think we'll be okay. This is old stuff. There's one new thing added, but most of this is old. All right, so factoring. What is the first rule of factoring? Always look for a greatest common factor. Now I will say this. As we progress through this unit, you have to do this. You have to find the GCF. If you don't find the GCF, life will be so much more difficult. GCF makes everything easier. So for this first problem, GCF is a 4y, which leaves us with x squared plus 5x minus 3. Second one, take out 8n, which leaves us at n minus 3. All right. Always focus on the first rule of factoring. Now, difference of squares. We've all seen difference of squares. Everyone has the idea x squared minus 4 becomes x plus 2, x minus 2. Now, this only happens when we're focused on subtraction. If we have a squared plus b squared, it is prime. It cannot be done. Now, giving another example, imagine we had x to the 10th minus 36y to the 6th. This would become x to the 5th minus 6y to the 3rd, x to the 5th plus 6y to the 3rd. What is key to be able to do this? We must have subtraction. We must have a binomial. We must have perfect squares. And coming off of perfect squares, you have to have an even exponent. Right? So if you're an even exponent, you're a perfect square. And, if we've forgotten, which I feel like I'm sure we're okay, remember, the idea here is that if we FOIL this back together, x to the 5th times x to the 5th, add the exponents to give us x to the 10th. And that's why this works. All right, some examples. All right, obviously, take a moment, pause, practice this, come back, check the work. 3, x squared minus 25, 3, x plus 5, x minus 5. All right, over here, 9, x to the 4th minus 1, 9, x squared plus 1, x squared minus 1. Key idea, not done. Now, again, along with the idea of GCF, this is the most common thing about your future exam. People do great work. They have everything right on their paper. They just don't finish problems. Right? So for this one, you know what? It's a binomial. It's subtraction, perfect squares, even exponents. We can take it further. So always make sure we are factoring everything to the very end. 5x minus 4, 5x plus 4. Now, there's two ways to go about doing this one. Right, so if I just took it exactly the way I saw it, 4 plus m squared, 4 minus m squared. Can go further. 4 plus m squared, 2 minus m, 2 plus m. Now, some people like reorganizing this. They feel that it has to be m in front. So if you need m to be in front, with this setup, we can't do it. But if we GCF a 1, there we have it, and this would become m squared plus 4, m minus 2, m plus 2, which in the end, this and this are the exact same thing. Doesn't matter which way you do it, but in the end, we must factor completely. All right, so there's our difference of squares. And again, continuing on with just basic factoring rules, kind of a refresh here. Trinomial, ax squared plus bx plus c. Key thing, we must find two numbers that multiply to c and add to b. So I have here just going on some blanks, and the idea is like, if it multiplies to a positive and adds to a positive, they're both plus signs. Multiplies to a negative and adds to a positive, is a positive negative. Now, the key thing with that is that the number with the plus is actually larger than the number with the minus. Down here, minus minus, because it multiplies to a positive adds to a negative. And here it's again positive negative, but the negative part of this number is larger than the positive. All right, so again, those are rules from the past. Now, as you've been doing these all along, we have an x to the second. Here we have an x to the first. Understand, this is half. The reason this works is because that middle term is half, and when we FOIL back together, x times x gives us x squared. So every time that the middle term is half, all these rules still apply. Now, key thing with these is that a is 1 for most of these. Right? So in this situation, a is 1, it's the only way it works. If a is not 1, we get some different ideas going on. But since it's x to the 6th and x to the 3rd, each bubble is led by x to the 3rd. Now, if it's a plus c and a minus b, minus minus. Ax squared minus bx squared. Right? It's half. FOIL back together. X squared times x squared gives you x to the 4th. Here we'd have plus minus. All right. Questions? Questions. I forgot that I'm not on Zoom. I literally felt like I was on Zoom for a second. All right. Obviously, you don't have questions because I'm talking to myself this time. All right. Take a moment. Pause. Try these out. GCF. X minus 4, x minus 2. All right, lead is x to the 4th, middle is x squared. We're good. X squared minus 4, x squared minus 3. Not done yet. O is factored till the very end. X plus 2, x minus 2. GCF, do not forget about GCFs. It will make life easier. X minus 16 plus 2. GCF again. X is 6 plus 2x to the 3rd minus 48. 2 x to the 3rd plus 8. X to the 3rd minus 6. And there's our final answer. And again, always check, am I done? Can I go any further? Now, a little future thing with problem 10. Problem 10, this can go further. Currently, based on the rules we have, it cannot go further, but we will add a cube factoring rule. Now, I do not expect you to notice at the moment, but I'm just showing you. X to the 3rd plus 8 becomes x plus 2 times x squared minus 2x plus 4, followed by the x to the 3rd minus 6. So for our very moment right now, yay, that's the answer. But in a week or two, yay, that's the actual answer. All right. So looking at the examples below, I don't necessarily love these examples. I think, 11 and 12 brings on splitting the middle term, what we're about to learn. Same with 14 is a little bit of splitting the middle term. But I guess 13 is a good one to look at right now. All right, so I assess 13, GCF. GCF here is 3, 81 a to the 4th minus b to the 4th. All right, so I check my binomial. Subtraction, perfect squares, even exponents. 3, 9a squared minus b squared, 9a squared plus b squared. Am I done? No. Take this further. 3a minus b, 3a plus b. Nice. All right, so 11, 12, 14. I wouldn't worry about them right now. On the next worksheet we do, it'll give you some better rules to be able to do those. If you're working on them right now, it's more of a guess and check mentality. Okay, let's flip over to lesson worksheet 6. We only got one new rule here and one old rule. Skipping the do now, going right here. All right, factoring rule number 4. First thing first, we cannot forget about rule 1. You cannot forget about, the GCF. The GCF is essential in everything we do. And I'm going to keep stressing it because, as always, I want people to succeed. I want people to get grades they're proud of. We have to make sure we pick up on the GCF. So far with factoring, we've looked at 2 terms. We've looked at 3 terms. We got difference of squares. We have sum product, normal factoring. Now we add 4 terms. So for those of you that know split and middle term, this is like partially the same thing. So if I look at example 1 right there, if I group the first 2 terms and group the back terms, if I take a GCF of my first 2 terms, 9x, I'm left with 5x plus y. Now, I have to GCF the next 2 terms and get the exact same bubble. So if I take out a negative a, I have 5x plus y. So the fact that I got the exact same bubble, that is great. So my answer is the GCF pieces and the common bubble. All right, more challenging problem. All right, rule number 1, GCF. And for the purpose of what I'm doing, I always take my GCF and move it off to the side. Too often, people leave it kind of like near the work we're doing, and they just kind of combine it, and it just, in the end, your final answer has to have an A in front. Don't do anything besides put that A in front at the end. All right, so look at my first 2 terms. If I take out a 2a, I have 4a squared minus y squared. If I take out a negative y, I have 4a squared minus y squared. All right, awesome. 2a minus y, 4a squared minus y squared. Oh, guess what? I can take this further. 2a minus y, 2a plus y, and I gotta put that a in front. There's my answer. All right, so again, the point I'm making with the GCFA is that people leave it near the work, and people tend to like combine the A and the 2A. No, not needed. They're separate, different ideas. Extra key idea. If ever given 4 terms, you can always reorder if needed. So maybe the 4 terms are set up in a way that's just not seeming correct to you. Reorder and try again. All right, for both of these 2 examples, if I reordered them, I'd be fine to still get the exact same answer. All right, last factoring rule, which goes with what we're just talking about. And the key thing here is that A is not 1. And by A not being 1, we have to separate that 11x to make it a 4-term polynomial. All right, so here's our rules. 2 times 12 is 24. What factors of 24 add to 11? 8 and 3. So I can now write this as 2x squared plus 8x plus 3x plus 12. Now it doesn't matter. You could have wrote it as 2x squared plus 3x plus 8x plus 12. Still get the exact same answer in the end. So going back up to here, take out a 2x, leaves me with x plus 4. Take out 3, got x plus 4. They have to have the exact same variable. 2x plus 3, x plus 4. Awesome. Down here, take out an x, leaves me with 2x plus 3. Take out a 4, leaves me with 2x plus 3. Same exact answer. It doesn't matter which way we do it. And in the end, with all these problems, you can always check by foiling your answers back together. All right, take a moment, practice 4 and 5, pause, come back to check your work. All right, so 6 times 35 is 210. What facts is 210 add to 31? 2110. 6x squared plus 21x plus 10x plus 35. Take out a 2x. No, I can take out 3. Take out 3x, leaves me with 2x plus 7. Take out a 5, leaves me with 2x plus 7. 2x plus 7, 3x plus 5. Four times 3 is 12. What factors is 12 add to 7? 4 and 3. 4x squared plus 4x plus 3x plus 3. Alright, so I take out, actually I'm going to change this one up for a second. Alright, so if I wrote it as plus 3x plus 4x plus 3, take out an x and I get a 4x plus 3. Now, 4x plus 3, 4x plus 3. It's already there, but you always have to GCF something. So what's the easy thing to GCF and keep it the same thing? Take out a 1. So if I take out a 1, I still have my 4x plus 3, and I have my piece. 4x plus 3, and x plus 1. Duh! Alright. So the examples below, we got some a little bit more challenging. I want to look at a few of them. Let's go with problem 4. So problem 4, my GCF here is 2x to the a power, which leaves me with 6x to the 2a minus 25x to the a plus 24. So a lot of people think that when you GCF to a, the a is gone. But remember, the idea, if I were to FOIL, if I were to distribute x to the a x to the a times x to the 2a. What do? X to the a plus 2a to give me x to the 3a. So that's why this works the way it does. So a lot of people make that error. GCF 2x to the a, you're left with what you're left with. And now we split our middle term. All right, take this, put that off to the side. 6x to the 2a. What do I got? 6 times 24 equals... Where's my calculator? Yes, I'm using a calculator. I'm lazy. $144. One fact is a 144. Add to negative 25. Negative 9x to the a. Negative 16x to the a plus 24. Group. Take out 3x to the a. 2x to the a minus 3. Take out an 8. I'm left with 2x to the a minus 3. 3x to the a minus 8. 2x to the a minus 3. And my GCF comes back in front. Alright, so problem 3. I look at problem 3. Key thing here is, you know what? I'm going to reorganize this. Alright, so the way it works here, would it work if I GCF? Right, so I'm going to reorganize it. I'm going to have it as 2x to the 4th minus 3x to the 3rd minus 8x squared plus 12x. Take out an x. 2x to the 3rd minus 3x squared minus 8x plus 12. Group. Off to the side. X squared, 2x minus 3. minus 4, 2x minus 3. X squared minus 4, 2x minus 3, x plus 2, x minus 2, 2x minus 3. And again, key thing, finish the problem, complete the problem. People make the biggest errors by forgetting to finish the problem. Right? So it's not necessarily an error. You did great work, but you left all the points on the table. And for problem 3, make sure you GCF. It's easier if you GCF. GCF will always make every single problem easier. Alright, for the sake of keeping this video on the shorter end, I'm going to stop here. And if you have questions when we all get back on Zoom, fire away, let me know what I can do to help.